and demonstration. So back to our sort of 4-step process. We've already developed a question and designed how we're going to come up with the answer. Next is to acquire the data, format our workspace, and fix any projection issues that we may have before we get started making a model. So we're obviously looking at flying squirrel in West Virginia. And if you're looking for spatial data in West Virginia, the single best source is the WVU GIS Tech Center. And there is the web address https://wvgis.wvu.edu/. If you go to this website, you'll find that it's a really awesome website. It has a lot of cool stuff. What we're going to do once we're there is we're going to look for land cover. The data set I'm going to use is the West Virginia Gap Analysis data set. It's a great land cover raster for the state. A lot of you are going to point out that it's old, and it is. In a real GIS world scenario, we would dig and claw and search and find and beg and borrow and do whatever we had to come up with the best, most current land cover data set that would meet our needs. This is just a demonstration, and I am familiar with, or more familiar with the land cover classes in this particular data set, and so we're going to use it. Like I said, if we were doing this professionally, we would definitely not want land cover analysis from 1999. We would look for something newer and potentially better. But again, data quality is defined as the fitness of a data set for its intended use. And if we need to know certain aspects of forest land cover and the newer data sets don't give us that information, then maybe this is the best data set. That's the kind of things that you have to look for and figure out if you're the analyst. Other thing we need to get is a digital elevation model, a DEM. Higher resolution is not better. County and state agencies across the globe are littered with high resolution data that they don't need. There is a time and place for better data, but better data is only better if it's actually better. And if you're just trying to do things like measure the forest, do you really need to know every 9 feet what forest type it is? Or is every, 90 feet sufficient? Or every 900 feet sufficient? These are good questions to ask, and the question will depend on what you're doing. My argument for what we're doing here today is really simple. We're trying to look at something across an entire state, and I'm doing a demonstration that students are going to use to do at home. And if they're operating off of a laptop and trying to process a 3-meter DEM of an entire state crashes it like 9-10 times before they get anything useful out of it, how is that a good thing? It's not. The trade-off between resolution and processing complications, it's just not there for this application. 30 meter is perfectly fine for what we're looking at. It still takes some time to process, but it's manageable. So we're going to download a 30 meter DEM for this project from the GIS Tech Center and move along. This project is a statewide endeavor, and so state planes not really going to work for us because a lot of times state planes is in a lot of states like West Virginia, the north and the south. And since we're looking at something that runs from north to south along the side of the state, because I kind of already know where the squirrels are at, then we can't really use this without making a lot of modifications. A better fit is the UTM zones because West Virginia almost completely fits inside of UTM zone 17. There's just a little bit out in the tip of the eastern panel that sticks out. And if we were in fancy GIS land, we would shift that zone 17 to the right, maybe like 10 miles or so, and we would very comfortably be all within the zone. But we're not going to do that, again, because this is just a simple demonstration for what we're doing, and more importantly, there's no squirrels over there. But also, the reason we're not going to worry about it is we're in raster and we know the grid size, and when we measure how much habitat's there to answer our question, it doesn't matter if it's been distorted or whatever over there because it's outside the zone. We're looking at the properties of each raster cell, and so if the properties match what we need, it gets counted. Doesn't matter how it looks. What matters is the data. And so it's not going to affect our analysis in this case, so even more reasons not to worry about it. But we do want to, at a minimum, follow some of the most basic projection-related guidelines, which is, students in my class know, we never do anything unless everything is in the same projection. On-the-fly projection is wonderful. We don't count on it. We're not going to get into that argument of what you can and cannot do across projections. We're just going to make everything in the same projection first and then do the work. So we're going to look at our data, and the stuff we're looking at is going to come from NAD 27 and NAD 83, and so we have to decide what works best for us. We're going to go with a little bit newer projection there. We're going to do NAD 83. We've already decided that we want to be in the UTM system, so we're going to go UTM Zone 17 North, NAD 83, and that's the projected coordinate system that we're going to choose for this project. The projected coordinate system for the map document for the data frame to UTM NAD 83 Zone 17 North. We're going to make a couple of folders for the stuff we're going to download. Data 1, Data 2, and Project SQ. Everything that we download, big old zip files, is going to go in Data 1. That's our reserve copies in case we mess something up. We're going to extract all the data from those zip files that's in Data 1 into Data 2. Data 2 is where we're going to put all this crap and whatever we make. And once we get everything worked out, we'll look at doing it a second time, in which case we'll go back to Data 1, extract that data again into the Project SQ. We'll then make only the files that we need in Project SQ, and our final map document we'll save in Project SQ. And so that when we're all said and done, we're going to have one neat folder that's going to have our map document, an unmessed up copy of the original data, and all the files that we created afterwards. And that's our basic premise for how we're going to do it. So we'll go sort of do that stuff, extract the data, get our map document, get it set in the projection we want. We're going to add some data, see if we have any sort of errors or problems or glitches that comes up. We'll fix whatever needs fixed and then move along with our modeling. So we'll go to the GIS Tech Center. We'll type in land cover. The Tech Center search engine is kind of specific. Turns out if you put in land cover as 2 words versus 1 word, you get different search returns. But the data set that I'm looking for is this land cover West Virginia gap that the green arrow is pointing towards. That's the one we're going to download. This is some information about it. It tells you a little bit about it, the data source, description of what it is. And then over there to the right, you see the download says UTM NAD 27. That's the spot where we're going to click, right there, where the circle just appeared. And that's going to lead us to the data we need. So the next is the elevation. I typed elevation in the search box. Up comes a bunch of results. The very one at the top is a 30-meter DEM from the NED, the National Elevation Data Set. There's a download link over to the right. You can click on the text to the left or the link at the right. Ultimately, it's going to get you to the same place. And it's going to take you to this page here. And these are just a couple of different links for what you can download. Slightly different files. They're all zip files. The The one we're going to download is this one here. It's the largest one, and it's the UTM-83 zip file of the newer data from October of. Well, actually, I don't know if this is so 10/8/02 could be October 8th, or it could be the 10th of August. It just depends on how the date's formatted, and honestly, you can't tell from this. So, as I said, I'm going to take this information and I'm going to download it into my Data 1 folder. There's the first one, and here's the second one. Ultimately, I will double click on one of these and extract it to my Data 2 folder. The next step in that process is opening up a blank map. You'll get that little getting started window. I just hit cancel. That opens up a nice empty, nothing in it kind of map. Then if there were the green arrow points, I'm going to right click on the layers and go down to properties and click on that. Once I click on the properties, it's going to open up the data frame properties. The interested tab for me is the coordinate system, and it doesn't have anything selected. I'm going to select a projected coordinate system, and I'm going to go down and find the UTM system, and then under UTM I'm going to find NAD83, and under NAD83 I'm going to find zone 17 north. There it is. Next step would be to start extracting the data, and so like I said before, it's all in data folder 1. I'm going to go to data folder 1. I'm going to right click on the data set, and I'm going to go to extract all. It'll pop open this. I'll browse to find the location of where I want to save this. This is going to be saved in data 2. And then I'll uncheck the box that says show extracted files when complete, and then I'll hit extract. And I'll do that for both of my data sets. Next step in the process, I'll go back into ArcMap and I will start adding in data. Clicking on the Add Data button right underneath the word selection there where the green arrow is pointing. When I do, I'll get this Add Data window. Because these folders are new and I've never used them before, they're not going to show up, and so I'm going to have to connect to them. Using this folder button over here on the right side of the Add Data window, the one with the little black plus, that's the connect to folder. I will then, from there, find the folder where the data is in and select the folder, not the data, just the folder, and click Add, and then that will add the folder I need in a little drop down there right beside where it says Look In, where right now it says West Virginia Gap. The folder that I select from that one inside the green circle there, that will then be added to that list, and then I can go there, select the data I want, add it into my map. Real simple. When I click on that black plus symbol there inside the green circle, it's going to come up with the connect folder. I'll simply go through the list of folders. This folder happens to be on my desktop, so it'll be desktop, and then go down and find, and I want to connect to data 2. I'll select data 2. I don't have to select those individual folders inside, just data 2, and click OK, and then move on from there. The moment I add this data in, like in this example here, I'm adding in this West Virginia Gap data set, you might get an error like this, unknown spatial reference. With this data set, you absolutely will, because the spatial reference information, while it is provided in an ample number of places, it's not integrated into the data set like it's supposed to be, and so it doesn't want to display properly. If you go back to the original data set download page and you scroll down after you've clicked on this one, you'll eventually get down to the information here about the coordinate system, and there you can see that this is in NAD 27 and it's in UTM zone 17 north. So if we go back and add the data into our map document, and we can go over into data management tools, projections and transformations, and we don't want to go to project raster, because we have to fix this before we can change the projection. We want to go to Define Projection. Define Projection tool, we load in the data that's missing the spatial reference. Under Coordinate System, it wouldn't have anything there. There where that green circle is, you click that little box, it gives you the options of selecting whatever, and we're going to ultimately select NAD 27 UTM Zone 17 North because that's what this data is. At this point, all the data is in two different projections, and reproject data we must. Not good is to have two. That's my best Yoda voice, and just like the Jedi, this isn't a mind trick. This is just good, honest, good guy logic. Um, get everything in the same format before you work with it. So we're going to reproject that now that we fixed it so that it matches the other data. So up next, we're now going to actually use that raster tool to use the project raster tool. Project raster comes up. We'll input the raster we just added the spatial information to. It'll then show us what the input coordinate system is. We will then select the folder for the output raster data set, which will be raster data, will be data2 is the folder we want. We'll give it the name we want. We'll then select the output coordinate system that we want. Because we're going from NAD 27 to NAD 83, which is what we want, we'll have to select a geographic transformation as well and then click OK. So when it comes time to select, you can go through the hard way through all the different projected coordinate systems to get to it, or if you scroll down to layers, because the other layer is in NAD 83, you can simply select NAD 83 from there. And once you run it, if you look over to the left in the table of contents, you'll see the new projected raster data set that we have there. That is the newly NAD 83 gap data that we can then use with our NED data to give us everything we need for our model.